All right, so this next section is about parallel lines and what we're going to call a transversal. So up at the top of the page, there are a number of vocabulary and angle relationships for you to know basically at the end of today's lesson. These are going to carry through into the next two lessons that we actually have, so today's kind of your introduction. First things first, we need to know what parallel and perpendicular lines are. Generally speaking, parallel lines are two lines that will never intersect. And they're also technically defined as always the same distance apart. So no matter where you go on the two lines, the distance between the two lines will always stay the same thing. So if we were to draw it, parallel lines could look like this, they could look like this, they could look like this, and be really far apart from each other, but they're always going to be the same distance. Real world example, if you're driving down the road, so if you have the lanes that are there, those would be parallel lines. Some people use the example of the railroad tracks. They're always the same distance apart, never going to change there. So those are all kind of options for you. There are plenty of other options as well. Those are just a couple for you. Perpendicular lines gets represented by this little symbol. It's an upside down capital T. Defining it in our own words, it's basically two lines that intersect. So they cross over each other. And when they do that, they form right angles. So everywhere it looks like a right angle. It's basically like if we were to draw a plus sign, and this is a right angle, that's a right angle, that's a right angle, and that's a right angle. So all of them form right angles. So real world examples of this, what could be a set of perpendicular lines? Maybe if you have tiles on your floor, kind of thinking here's the tiles, and they intersect in a perpendicular line. That could definitely be an option for you. You could see just the plus sign if we're talking about math. If you had an intersection for cars, so kind of coming in, you could have this road and this road could be perpendicular because they form a plus sign just like that. Again, just a couple examples there for you. So here's the real stuff for today's lesson. We are going to be working with parallel lines, and parallel lines get designated by these little arrow heads that are on here. So this tells me that these two lines are going to be parallel. They're never going to touch each other. This line that comes in here and intersects the parallel lines is what we are going to start calling a transversal. The word trans means going across. So if you think the Titanic with its transatlantic voyage, it was going across the Atlantic Ocean. So transversal is a line that goes across your two parallel lines. So a couple things to notice before we get hooked on angle relationships here. With the two sets of parallel lines, there's kind of this area that we can call quote unquote inside. And inside, another word for that is going to be the interior. So those are going to be interior angles. 3 and 4 and 5 and 6 are all interior angles. This part that's outside here then would be called the exterior because they're found on the outside parts of the parallel lines. So here we go. We are going to add to your vocabulary 6 new vocabulary words. Actually, really only 4 new vocabulary words. Because corresponding, which is our first vocabulary, corresponding angles, you've already heard the word corresponding. And thinking back to your old definition, corresponding meant that they were in the same spot. Remember, we talked about that with similar figures. So what I want you to do is to take a look at these 4 angles that are located up here and these 4 angles that are located down here. Now, if you were to take this set of angles and actually slide them down on top of these angles, you would probably be comfortable saying the 1 would slide down on top of the 5, the 2 would go to the 6, the 3 would go to the 7, and the 4 would go to the 8. They're technically located in the same spot when I consider what I'm going to call these clumps of angles here. So because they are in the same spot, they're actually corresponding angles. So angle 1 and angle 5, because they'd slide to the same spot, would be them. Angle 2 and angle 6 angle 3 and angle 7, and angle 4 and angle 8. Corresponding angles are going to be in the same spot. Now, it should make sense to you then, since they're in the same spot, that they are actually going to be congruent. So corresponding angles are congruent because if they're in the same exact spot, they should be the same exact thing. Hopefully that makes sense to you. Go on to the next one. So we have alternate interior. So first of all, I see the word interior, which tells me that we must be focused on this interior section. So we're looking at these 4 different angles that are located inside here. Since the word alternate is in there, it means that we have to be alternating, or we have to go back and forth. So there's kind of 2 ways to remember this. We need one from this group and one from this group, but they also have to alternate sides of the transversal. So if I started here at angle 3, I need to go to the other group and I need to jump the transversal, which would take me down here to 6. So angle 3 and angle 6 are actually an alternate interior pair. With that in mind, hopefully you see that 4 and 5 would be the other alternate interior angle pair. In this case, we only have those 2 sets because there's only 4 angles on our interior at this spot. Go to the next one. So if we say alternate exterior, you're thinking to yourself, we're on the exterior now. Think the same idea, alternate exterior. We have to alternate back and forth. So if we start up here at 1, we're only looking at exterior angles, so we're going to come down here to 7 and 8. Which one's on the opposite side? The 8 would be. So 1 and 8 are alternate exterior angles. Same concept, 2 and 7 would also be alternate exterior angles. All right, take a look at same side interior. So again, now we're just focused back on these 4 interior angles, and now we want ones that are on the same side. So if I start with 3, to stay on my same side, I'm going to jump down to the 5. So angle 3 and angle 5. The other set that I have would be the 4 and the 6. So that's my only 2 sets since I only have 4 of them. Same side exterior, you're probably thinking we're on the outsides now. Yes. So if we start with angle 1, we would stay on the same side. We're going to come down here to angle 7. If we start with 2, stay on the same side, we have to come down here to angle 8. So angle 2 and angle 8 then. Now, last thing, vertical angles. So you already know verticals, they're just across from each other. So we have angle 1 and angle 4, 2 and angle 3. We have angle 5 and angle 8, and we also have angle 6 and angle 7. Now, let's kind of use this information because we only talked about the relationship that corresponding angles have. So if I talk about alternate interiors, so I want you to think for a second. Remember, if we actually slide these down, so I'm going to actually redraw this picture here. We have 5, 6, 7, and 8. And if we slid these down, 1 would go here, 2 would be here, 3 here, and 4 here. Now, keep in mind our alternate interior angles are 3 and 6. Notice how they're related. Once we do the angle slide, they're actually vertical. So these alternate interiors in 4 and 5, they're actually also going to be congruent to each other. Now, they are not technically vertical because the slide has to happen first, but in order for us to see a relationship, we're able to see it using this idea. How about the alternate exteriors? So we had 1 and 8, 1 and 8. The other pair was 2 and 7, 2 and 7. Notice in our conjoined picture here that they're actually vertical again, so alternate exteriors are also congruent. So far corresponding is congruent, alternate interiors and alternate exteriors are congruent. What about same side exterior? So we're looking at 3 and 5. So here's 3 and here's 5. Notice that together they actually form a linear pair, so they're supplementary to each other because they make 180 degrees. Same thing if I look at 4 and 6, they're a linear pair, they're supplementary. Same side exterior, 1 and 7, 1 and 7, supplementary. 2 and 8, supplementary. The other way that I think about these, same sides are supplementary. S, 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 S. Same side supplementary, same side supplementary. Doesn't matter if they're interiors or exteriors. Vertical angles, you already know, these guys are congruent. Okay? So flip it over. Real quick, just identifying these. Take a second, fill it in, and come back and check your answers. All right, you'll notice that I did put down kind of some shortcuts here, but those are your answers. So pause your video, double check your work. The last example is just a real life example. So we have furniture designer built the bookcase, A and B are parallel. Measure of angle 2 is 105 degrees. So it wants us to find 6 and to also find 3 then. So we need to justify our answer. So hopefully you're saying angle 2 and angle 6 are going to be equal to 180 degrees because they are a linear pair. So if angle 2 is 105, angle 6 is what you're looking for, so angle 6 would have to be 75 degrees. And your justification is linear pair or supplementary. Those are your two options there. So in order for us to find angle 3 though, if we looked, 2 and 3 are same side interiors, so we could use the fact that same side interiors are supplementary. Or we could use the angle slide, bring 2 down to 4, so this is actually 105, and these would also have to be a linear pair then as well, which tells me that angle 3 is 75 degrees, and we could put, again, same side interior or linear pair based on if you did the angle slide.